Hello students, welcome to the next lecture on the complex analysis. Today we will discuss about the concept of the logarithm of functions in the complex variable. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel. What we have discussed so far, we learned the concept of the exponential functions and we have seen the exponential function is always the periodic functions with the period 2 and pi iota. Moreover, the exponential function is not 1 on the domain, on the complete domain complex numbers. However, if I change, because we all know z is x plus iota y, if I change my domain, that is z belongs to the C, if I change the domain to some another one, let's say H, where H is defined as collection of all those elements of the x and y, where y is only from the minus pi to plus pi, and then the exponential functions of the complex variable is a bijective functions. That means it is a 1 as well as onto. Further, we all know in the complex in the calculus, whenever we have written x is equal to e raised to power y, I can written as y is equal to ln of x. That means I can say e raised to power ln of x is equal to x. Fine. Or you can say ln of x is the inverse of the x. Fine. That we all knows in the real analysis. Fine. यही हमने देखा हुआ है. फाइन. whenever you have write e raised to power ln x, इसका क्या मतलब होता है? That means ln x is the inverse of the e raised to power x. Now our target in this lecture is to learn क्या ये same चीज complex variable में भी possible है. Our goal in this lecture is to define any function, let's say log of z, such that e raised to power log z is equal to z. That means our target, what is your target? Our target is to find the expression of the log z. Our target is to find the expression of the log of z. Fine. Remember students, if z is my real number, fine, then these equations hold. If z is a real number, then we can always say e raised to power log z is z. Fine. लेकिन अगर ये complex number है, then the big question mark arises here. Fine. Then how we can deal with them? So we will see in this lecture deeply. So our target is to want log of z to be the inverse of the e raised to power z. Now, what is the basic difference between the log x and the log z? We all know, can you find the value of the log of 1? Because 1 is a real number, answer is 0. What is the value of the log of minus 1? Which is undefined, because log negative is not defined. Moreover, if I say what is the value of the log of x, where x is my real number, that is always be the single valued function. सिंगल वैल्यू मतलब एक ही आंसर आएगा ना आपके पास. मान लीजिए अगर आपने log of 7/9 ले लिया, तब भी एक सिंगल आंसर आएगा. अगर आपने log of 10 ले लिया, then again it's a single answer, and so on. Fine. On the other hand, whenever we are talking in the complex analysis, fine, log of 1 is not 0 always. फाइन. इसका मतलब log of 1 की कोई और वैल्यू भी हो सकती है, 0 भी हो सकता है, but not always. Second is log of -1. In the real analysis, it is undefined, it is well defined. Fine. And the last thing is, whenever you have taken the log of z, he said whenever x is a real, it's a single valued, but log of z is a multi-valued. Multi-value means एक पॉइंट पे किसी के एक से ज्यादा आंसर भी आ सकते हैं. लाइक log of 1 is 0, fine, and log of 1 is 2 and pi iota as well. Fine. ये दो अलग अलग आंसर आपके पास हैं इस केस में. Fine. So सबसे पहले I will tell you why the log of z is a multi-valued function. Fine. Now remember students, we all knows what is the value of the e raised to power 0. e raised to power 0 is 1. Fine. तो इससे क्या मतलब हुआ? ln of 0, sorry, ln of 1, ln of 1 is my 0. यहां से तो यही कंक्लूजन मिला आपको एक पॉइंट पे. फाइन. ऑल्सो वी नो because e raised to power z is periodic function. Fine. What is the period of the 2 pi iota or 2n pi iota? Fine. I can say 2n pi iota is also 1. That means log of 1 is equal to 2n pi. फाइन. और 2n पाई आयोटा. फाइन. इन दो पॉइंट से क्या कंक्लूजन मिला आपको? log of 1 is 0, log of 1 is 2n pi iota. That means log of 1 is a multi-valued function. Fine. So in general, we can say log of z is a multi-valued function. Now, multi-value का क्लियर हो गया मतलब? yes, मतलब उसकी एक से ज्यादा वैल्यूज आए. Now, if I consider any complex number which is a non-zero, let z is equal to z, non-zero z be any complex number. Fine. तो इसका मतलब क्या होगा? That means I can write z is x plus iota y, or I can write in the polar form is r e raised to power iota theta. Then our target is to define what is the value of the log of z. Fine. Because it has a multiple value solution. So what is the exact formula or what is the exact equation of the log of z? So our target is to find w such that e raised to power w is equal to z. और that means our target, इससे क्या conclusion निकलता है? That means w is the inverse of z. यही तो मतलब हुआ ना. अगर w की वैल्यू आपकी log z आ जाती है, then log z is the inverse of the z. अगर w की वैल्यू आपकी कुछ भी आ जाती है, let's say phi of z और sin of z और 1 over z and so on, जो भी आएगी that we call as the inverse of the z. Fine. So now let's see how we can find that. So once we have considered z is x plus iota y, fine, or I can consider z is equal to r e raised to power iota theta. What is my theta is? Theta is my argument of the z. Fine. R is the modulus of the z. Fine. And this z is called as the principal value or as the general value. Fine. If I consider the polar form of the complex variable z, fine, polar form of the w or the Cartesian form of the w or Cartesian form of the z, I can take z is equal to r e raised to power iota theta. Fine, where theta slices from minus pi to plus pi and w is my u plus iota v. If I substitute on the given equation, then e raised to power u plus iota v is r e raised to power theta. I can open this e raised to power u, e raised to power iota v, which is equal to r e raised to power iota theta. Fine. I can equate the components. What is the real component on the both side? The real component is e raised to power u is equal to r. What is the imaginary component? Imaginary component is e raised to power iota v is e raised to power iota theta. And because we all know exponential is a periodic function, fine, I can write v is equal to theta plus 2n pi. Clear? And make sure students, इसमें u और v क्या होते हैं आपके पास? u and v are my real numbers. Clear? अब आप देखो, अगर ये आपको रियल है तो यहां से बिकॉज u is my real, तो रियल एनालिसिस के तरह u की वैल्यू निकाल सकते हो आप. तो u will be ln of r. फाइन. अगर u आपको ln of r मिल गया, v आपको मिल गया 2n pi plus theta, can you find the value of the w? u plus iota v. What is the u? U is ln of r plus iota times 2n pi plus theta. That is my w. फाइन. और हमारा टारगेट भी w निकालने का था, वेयर n is my z, और I can write w is nothing but log of z from the equation number 1. So that means log of z is nothing but log of r plus iota into 2n pi plus theta, where theta is the principal argument of the complex number z. So based on this equation number 2, I can define the complex functions or multi-valued logarithm functions as here. फाइन. और अगर आपके पास x की वैल्यू और z की वैल्यू कार्टेशियन फॉर्म में है, देन व्हाट इज द r? r is nothing but root of x square plus y square, that is the modulus value. Fine. And theta is my principal argument value. So I can replace the value of the r to be mod of z. Fine. 2n pi plus principal argument value. This is the principal argument value. Fine. So modulus, while mod of z is the modulus of the complex number z. Fine. Now, as I mentioned you, argument is a principal argument value which is defined as tan inverse y over x, and it lies from minus pi to plus pi. Now we can define the complex logarithm function, the function log of z, और जैसे मैंने बोला, this is the modulus. Fine. And small arg. Small arg means that is a general argument which is defined as 2n pi plus capital ARG. Capital ARG is known as principal argument. Fine. For more details about the difference between the small ARG and the capital ARG, I recommended you can watch my previous lecture, modulus and the argument. Fine. Now, let's say how you can find this number. So, सबसे पहले, if I take z is equal to 1, I can write this in the complex number iota 0. Fine. Now, can you find the modulus of z? It will be root of x square, imaginary square plus real square, that will be 1. Now, clearly it lies in which quadrant? 1, 0. It lies in the first quadrant. So, what is the value of the theta? That is ARG, capital ARG. That is my tan inverse y over x. Y is my 0. So, it lies in the first quadrant, angle is 0. Therefore, small ARG is 2n pi plus capital ARG. Capital ARG is my 0. So the answer is 2n pi. I can substitute both the values. Mod of z is my 1. Small ARG will be 2n pi. So log of 1 will be 0. Answer is 2n pi. Iota is the answer of the log of 1. Fine. Similarly, we can find for the log of minus 1, where the minus 1 lies. Minus 1 lies in the second quadrant. I can write in terms of, fine, what is the modulus? Modulus is again 1. Fine. What is my capital ARG? Because it lies in the second quadrant, 0 over minus 1. And this capital ARG is always lies between open interval minus pi to, fine, so that will be 0, but 0 तो आपका second quarter में lie नहीं कर रहा, that is the pi. I can write this number is my pi. So therefore I can substitute the value. What is the value of the log of minus 1, which is equal to log of mod z plus iota small arg, that is a 2n pi plus capital ARG. Fine. I can substitute both the values. Log of 1 is a 0. 2n pi plus pi. So I can take an pi as a common. 2n plus 1 pi iota is the right answer of the problem. Okay, now some remark about this definition number 1. Fine. First of all, log of z, because small arg का formula में क्या आ रहा है? N, and n has infinitely many values, so therefore log of z has infinitely many values. Also, we know if I consider z is my 0, then clearly say argument of the z is not defined. Fine. Therefore, log of 0 is not defined. Clear? Because argument of 0 as well as modulus value, log of the mod of 0, ये दोनों values आपकी proper defined नहीं है. We can say log of 0 is not defined. Second is, we always choose the branch of the argument. Find branch of the argument means, as we can see, it has infinitely many values. Fine. अगर आप इसकी single value चाहते हो आप, once you can make a single value, it means you have to choose the n as a fixed number. Fine. If you choose n is my fixed number, then we will get as argument of z is my single valued function. Fine. Once the argument of z is my single valued, then log of z is also single valued, and that is called as the branch of the argument. Fine. We will discuss the branches of the logarithm function in detail in the separate video in the next part. Fine. And the principal part, if I restricted my small arg to be the principal value of the, that is a minus pi to plus pi, then we call as a principal branch of the logarithm function. So that branches of the logarithm function we will discuss in a separate video. Chaliye, for example, first of all, you can see where the value of the z is 1 plus iota lies. So 1 and iota is 1. So that is lies in the first quadrant. Fine. So your target is to define the value of the log of z. So clearly say z is equal to 1 plus iota lies in the first quadrant. Fine. Now can you calculate the absolute value or modulus? It is 1 plus 1. मैं आपको रिकॉल करवा दे रहा हूं, अगर आपको अभी रिमेंबर नहीं है, how you can find the modulus value, that will be root of real part square plus imaginary part square, that will be root of 2. Second is we need a theta. Theta is the principal argument, capital ARG, that is defined as tan inverse y over x. Y is my 1, x is my 1. So tan inverse of 1, that is my pi over 4. And make sure this value must lies between minus pi to plus pi. And pi by 4 lies in that. So therefore, your theta is pi over 4. And modulus value, that is the argument, modulus value of the z is root 2. I can substitute both the values in this given equations. That will be 2 raised to power 1 over 2 plus iota 2n pi plus pi over 4. I can take an half is outside, ln of 2 plus I can take an 2n plus 1 over 4. Pi is my common, pi iota, where n is my integer. Fine. Or you can take an 4 is LCM and so on. Fine. तो आप यहां से भी देख सकते हो, for the different value of the n, log of 1 plus iota has different values. Shall you look at the next one? Again, your target is to find the expressions of the log of z. Fine. आपका हमेशा फर्स्ट स्टेप यही होगा, इसको चेक करिए कहाँ लाई करता है. z is equal to minus 1 plus root 3 iota. X is equal to minus 1. Y is equal to positive. That lies in my second quadrant. Fine. So you can find the modulus. Modulus value will be root of x square plus y square. Real part square plus imaginary part square. That number will be 1 plus 3. That is my 2. Fine. You can find the argument tan inverse y over. So that will be root tan inverse minus of root 3. फाइन. तो tan की वैल्यू रूट 3 कब होती है आपके पास? दैट इज माई 60 डिग्री. फाइन. बट इट लाइज द सेकेंड क्वाड्रेंट. 60 तो आपका यहाँ पे लाई करेगा ना. तो हाउ यू कैन दैट? दिस इज माई पाई. आई कैन रिटर्न एज पाई माइनस, because it's a negative, of the pi by 3. So the answer is 2 pi over 3. Fine. Is it okay? Now I can substitute the value of the modulus z. 2 argument is 2 pi over 3 in this final expression, and you will get the required answer of the log 1 minus 1 plus root 3 iota. Similarly, you can see for this third case where it lies minus 3 minus of root 3. It lies in the third quadrant. Fine. So can you find the argument value? That is my tan inverse y over. So that will be tan inverse 1 over root 3. तो ये कितना हो जाएगा आपका 30 डिग्री. दैट इज अ पाई बाय 6. but pi by 6 lies in the first quadrant, but our target is to need as the second quadrant. लेकिन अब आप इसमें ये भी नहीं कर सकते, because this value is my pi, pi plus pi by 6 भी नहीं कर सकते आप. Why? Because this value of the theta is lies between minus pi to प्लस पाई. लेकिन ये वैल्यू तो इससे भी बाहर चली जाएगी ना. तो आपका क्या रूल बताया था मैंने प्रीवियस लेक्चर में, यू कैन ऐड माइनस पाई इन दिस केस. फाइन. तो आंसर इज माइनस 5 पाई बाई 6. Fine. Now substitute both the values. What is the mod of z? Which is equal to 3 square. Minus 3 square is 9. Root 3 square is, so root 12. Root 12 you can write as a 2 root 3. Fine. Or I can write as a 12 raised to power 1 over 2. 1 over 2 I can take in is outside. Similarly for the fourth case, where it lies, x is equal to positive, y is equal to negative. It lies in the fourth quadrant. Fine. So can you find the value of theta? Theta is tan inverse y over x. So that number is minus pi over 4. And minus pi over 4 lies in the fourth quadrant. And moreover, it also lies between minus pi to plus pi. Fine. Can you find the modulus value? Modulus value is 1 plus 1, that is a root of 2. I can substitute both the values in the required expression of the log of z. Then you will get the right answer of the problem. Now, once we know how we can calculate the logarithm, then the another most important concept is the principal value. Fine. Principal value का मतलब क्या है? सबसे पहले आपने ये देखा कि log of z has infinitely many values. Fine. For example, जैसे मैंने आपको पहले बताया था, log of 1 क्या है आपके पास? 2n pi iota. Also, log of 1 is my 0. Fine. So your target, fine, or you can say this is my complex value function. Iota आ गया ना उसके अंदर. This is the complex value. Fine. And real analysis में log of 1 कितना होता है आपका? 0. Real analysis. Fine. क्या आप n की कोई एक ऐसी वैल्यू चूज कर सकते हो जिससे कि कॉम्प्लेक्स एनालिसिस का आंसर रियल एनालिसिस से मैच हो जाए? क्या आपको यहां से n कहां बिलोंग करता है? z के अंदर. क्या इस z में आप कोई एक ऐसा n चूज कर सकते हो जिससे कि ये वाला आंसर जो है 2n पाई आयोटा इज इक्वल टू द 0 हो जाए? तो यस, यू कैन चूज n इज बाई 0 बिकॉज 0 इज द पार्ट ऑफ द z. तो जैसे ही आप n की वैल्यू 0 लोगे तो आपका log of 1 0 बन जाएगा. That means the result match with the real analysis. Fine. So that is the value of the principal value. Fine. So as I have discussed, log of 1 has infinitely many values, but the real logarithm has only single value. So my target is, can we get a real value from the case of the infinitely many values? The answer is of course yes. Fine. And how you can do that? You can simply take n is equal to 0. Fine. If I choose n is equal to 0, then it becomes my real logarithm function. And that is the definition of the complex principal value of the complex variable. और principal value of complex variable को हम capital LOG or you can say the capital LN से लिखते हैं. That means in other words, I can say जो भी आपका complex का formula था, if I choose n is my 0, तो ये चीज खत्म हो जाएगी आपकी. Fine. And that expression is called as the principal value of the logarithmic function. Fine. तो इसका मतलब प्रिंसिपल वैल्यू आपके पास एक यूनिक वैल्यू आपको प्रोवाइड करेगा. दैट्स अ सिंगल वैल्यू. क्लियर? अगेन जैसे मैंने पहले बताया आपको, लॉग ऑफ कैपिटल लॉग इज द प्रिंसिपल वैल्यू, और अब ये कैपिटल ARG हो गया आपका सिंपल, दैट इज अ प्रिंसिपल वैल्यू. और प्रिंसिपल वैल्यू की वैल्यू है आपके पास माइनस पाई टू प्लस. अगर आप इसको पोलर फॉर्म में लिखना चाहते हो, सो पोलर फॉर्म में आपका z क्या होता है? फाइन. वेयर थीटा इज माय प्रिंसिपल आर्गुमेंट. सो इफ यू टेक द कैपिटल L, that will be log of r plus iota of theta. क्लियर? अगर मैं आपको इसकी एग्जांपल्स की वैल्यू निकाल के दूं, फिर से पहले देखते हैं. वेयर इज द आयोटा लाइज? आयोटा को मैं क्या लिखता हूं? 0 प्लस आयोटा. इट लाइज इन द फर्स्ट क्वाड्रेंट. फाइन. देन व्हाट इज द वैल्यू ऑफ द, you have your target is find the capital log. So what is the modulus of z? modulus of the z is my 1 plus iota. What is the capital ARG? Capital, that is the tan inverse y over x. Y is my 1, x is my 0, that's infinity. Answer is pi over 2. Log of 1 will be 0, so the answer is iota pi over 2. Similarly for the second one, it is a log of 1 because उस केस में आपके पास -1 प्लस आयोटा 0 हो जाएगा. इट लाइज इन माई सेकेंड क्वाड्रेंट. तो सेकेंड क्वाड्रेंट में आपका एंगल कितना हो जाएगा? दैट इज अ पाई प्लस iota times pi. Similarly, z is equal to minus of iota, where it lies. X is 0, y is equal to -1, lies in the third quadrant. Argument modulus is my 1. Argument will be minus pi. Fine. Sorry, minus pi by 2. And so, fine. And then you can easily calculate the principal values of the. Otherwise, आप क्या करिए? आप स्मॉल लॉग ऑफ ये निकाल दीजिए इंस्टेड ऑफ द कैपिटल लॉग. ओके, जो भी इसका आंसर आएगा देन यू कैन टेक n इज माई 0. फाइन. What is the difference between the log of small log z and the principal value? This is, remember, this is the principal value and this is the general logarithmic function. So as we have seen, if I open the bracket, then what will happen? This is iota times capital ARG plus iota times 2n pi. ये चीज क्या बन गई आपकी? That is nothing but my principal value of the logarithmic functions plus 2n pi iota is the right answer. और आप देख भी सकते हो whenever n is my 0, fine. और इस एक्सप्रेशन से क्या मिला आपको? The general logarithmic functions and the principal value of the logarithmic functions are same. Moreover, if you consider x is any positive real numbers, x is my positive real numbers, so अगर अकेला real है तो z, how I can write? X plus iota into 0. It lies in the first quadrant. अगर ये first quadrant में है then what is the value of the argument? Fine, is my 0. तो अगर एंगल 0 आपके पास, that in that case principal value or you can say the capital log is equivalent to the ln of x function. But ये तभी है अगर आपके पास x is a positive real number. अगर पॉजिटिव कॉम्प्लेक्स नंबर है और नेगेटिव कॉम्प्लेक्स नंबर है देन दिस रिजल्ट मे और मे नॉट होल्ड. चलिए अब कुछ एग्जांपल से समझाते हैं आपको. कैलकुलेट द लॉग ऑफ जेड. अगेन आपको लॉग ऑफ जेड का मतलब स्मॉल लॉग बोला ना आपको. फाइन. तो ये किस क्वाड्रेंट में लाई कर रहा है? थर्ड में. कैन यू फाइंड द वैल्यू ऑफ द थीटा? tan इनवर्स y ओवर x √3. तो ये तो पाई बाई 3 हो गया, लेकिन पाई बाई 3 इज लाइज द फर्स्ट क्वाड्रेंट. आपको तो चाहिए थर्ड में, सो दैट विल बी, आई कैन राइट एज माइनस पाई प्लस पाई ओवर 3. सो आंसर इज minus 2 पाई ओवर 3. आई कैन सब्सटीट्यूट थीटा इज minus 2 पाई बाई 3 और मॉडुलस ऑफ जेड कितना हो गया आपके पास? रूट रियल स्क्वायर प्लस इमेजिनरी स्क्वायर, दैट विल बी 2. I can substitute the modulus value as my 2 and minus 2 pi by 3 is the argument answer. Fine. So you will get answer is log of z is log of 2 plus iota. Clear? और ज्यादा से आप इसकी एलसीएम ले लीजिए and then you will get the right answer. प्रिंसिपल ब्रांच के लिए क्या करना होगा आपको? You can simply choose n is equal to 0. यहाँ से n 0 कर दीजिए. Then your answer will be ln of 2 minus 2 pi by 3 iota is the right answer. Look at the next one. Compute all those values of the log of iota. Fine. So iota lies in which quadrant? I can write as a 0 plus iota, that lies in the first quadrant. X is equal to 0, y is equal to 1, that lies in the first quadrant. तो पहले तो आप थीटा निकाल लीजिए. tan इनवर्स y over x, that will be tan inverse infinity. tan की वैल्यू infinity कब होती है? पाई बाई 2 पे ऊपर. फाइन. एंड व्हाट इज द मॉड ऑफ z? आपका z क्या था? 0 प्लस आयोटा एंड मॉड ऑफ z विल बी 0 प्लस 1 विच इज 1. अब जैसे आप यहाँ पे फिल करोगे log of 1 प्लस आयोटा 2n पाई प्लस पाई बाई 2. log 1 is 0. I can take an pi is a common, so that will be 4n plus 1. I can take LCM as well. So that means log of z is my iota, is defined as 4n plus 1 pi by 2. How you can find the principal value? If I substitute n is equal to 0, then the left hand side becomes capital log of iota will be, if I take n is 0, that is pi by 2 iota is the right answer. Find the principal value. Again, you can see z is equal to iota. Z is equal to iota अभी करा हमने. Find it lies the first quadrant. So theta will be pi by 2. Fine. और principal value लेनी है तो आपका n 0 होगा. That means your target is to find the log of z, which is ln of plus iota times theta. Fine. तो इसका मॉडुलस कितना हो जाएगा z का? 1. So log 1 is 0 plus iota pi by 2 is the right answer of the problem. Fine. This is the first method जिस तरह से अभी हमने करा है. Otherwise आप इसको पोलर फॉर्म में भी लिख सकते हो. Write in the polar form. Fine. Iota की पोलर फॉर्म क्या होती है? पोलर फॉर्म के लिए आप ये लिखोगे ना. Fine. So that will be iota times pi by 2. Then you can find the log of z. Fine. Argument तो 1 आया ना आपका. So I can choose as a log of 1 plus ln of e raised to power iota pi by 2. Log 1 is 0 plus iota pi by 2, which is the same answer as we obtained by the method 1. Fine. ऐसे तो निकालते थे ना. r की वैल्यू क्या होती थी आपके पास? That is a root of x square plus y square, and theta is the principal argument of the z. Fine. चलिए look at the second one. z is equal to 1 plus iota. किस quadrant में लाई करता है ये? Yes, it lies in the first quadrant. X की value 1, y is my positive. Fine. Can you find the modulus? It is root of 1 plus 1. That is my root 2. Theta, that is a capital ARG, which is tan inverse 1. Tan inverse 1 is my first quadrant में है तो pi by 4 आपका आंसर हो गया. So if I substitute the principal value, that means the capital log, which is ln of root 2 plus iota times argument. इसको मैं क्या लिख सकता हूँ? 1/2 पावर को आगे ले लेता हूँ, हाफ ln of 2 plus pi over 4 iota is the right answer of the problem. Look at the third one. Where is the minus of 2 lies? I can write as a minus of 2 plus iota 0. Minus 2 lies in the second quadrant. Fine. That number lies in the second quadrant. Fine. So what is the angle? Tan inverse y. So minus 2 plus 0 iota. 0 over minus 2. That's a 0. But second quadrant में तो 0 आएगा नहीं ना, तो आप इसमें pi plus कर दीजिए. Fine. So theta will be my pi. And what is the modulus? This is real component square plus imaginary square. Answer is my 2. Modulus value हमेशा positive square root होती है हमेशा. Fine. So z is my 2. Theta is my pi. I can substitute the value in the given expression. You will get the answer of the principal value of the minus 2. Now, once you learn the concept of the how you can find the log of z, how we can find the principal value of the log z, then our target is to find the solution of e raised to power wz. तो अगर ये अभी मैंने क्या दिखाया आपको, w is nothing but log of z ही तो है ना. फाइन. तो इसका मतलब जो जब भी आपको इस तरह से इक्वेशन मिले लाइक e raised to power w, find the value of the w, your target is find w. मतलब w की ऐसी कौन सी वैल्यू लें कॉम्प्लेक्स वेरिएबल में जिससे आंसर -2 आ जाए. इस वाले केस में 1 प्लस आयोटा आ जाए और इसमें आयोटा. फाइन. सो देयर आर द टू वेज. फर्स्टली you can find the log of whatever the right hand side is given to you and compare them. Fine. So as I mentioned you, log w is nothing but my log of z. Fine. और इस log z को कैसे लिखते हो आप? It is defined as log of absolute value plus iota 2n pi of argument. Fine. ये मैं पहले बता चुका हूं. It's a real absolute value and it's a principal argument value. So look at that. अगर मैं इस इक्वेशन को इसके साथ कंपेयर करूं, व्हाट इज अ जेड फॉर द फर्स्ट पार्ट, जेड इज इक्वल टू iota. That means your target is to find the value of the log of iota. यही तो होगा ना. और अगर आप यहां से देखो, how you can write that w is nothing but my log of iota. बस फिर से आप देख लो, iota lies in the first quadrant. फाइंड, अगर ये फर्स्ट क्वाड्रेंट में लाई करता है तो मॉडुलस वैल्यू कितनी होगी इसकी 1. आर्गुमेंट कितना हो गया, tan इनवर्स 1 by 0, that is pi over 2. Clear? So as you can say, if I take z is equal to iota, my target is to find the value of log z. It lies in the first quadrant. I can find the modulus value. I can find the argument value. If I substitute log of 1 plus iota times 2n pi plus pi over 2. Log 1 will be 0. I can take LCM 4n plus 1 pi over 2 iota. Fine. So therefore यहाँ पे फिल कर दो. तो W की वैल्यू कितनी आ गई, 4n plus 1 pi over 2 iota is the right answer of the problem. Fine. मतलब अगर आपसे प्रिंसिपल, यहाँ कभी भी, यहाँ देखिए कहीं पे भी प्रिंसिपल वैल्यू तो नहीं लिखा. क्या ये प्रिंसिपल वैल्यू लिखा है? नहीं लिखा. तो आपका आंसर इन टर्म्स ऑफ n होगा. फाइन. n इज माई जेड. इट कैन बी पॉजिटिव, इट कैन बी नेगेटिव. आप कोई भी वैल्यू फिल कर लो. जैसे आपने n 0 फिल करा तो आंसर विल बी पाई बाई 2. इफ आई सब्सटीट्यूट 1 देन 5 पाई बाई 2. इफ यू सब्सटीट्यूट -1 then it is -3 pi by 2 and so on. Fine. So all are the solutions of the equation. इसका मतलब जैसे मान लो मैंने पाई बाई 2 फिल करा, तो e रेज़ टू पावर पाई बाई 2 आयोटा. फाइन. अगर मैं इस पे डी मॉर्गन्स थ्योरम लगाऊं, सो e रेज़ टू पावर पाई बाई 2 आयोटा इज cos पाई बाई 2 प्लस आयोटा sin पाई बाई 2. And clearly say cos pi by 2 is 0, sin pi by 2 is 1. So that is my iota. Fine. So you can see that it has infinitely many solutions. Look at the next one. 1 plus iota. Again, it lies in the first quadrant. What is that? Theta. Tan inverse 1 over 1, which is pi by 4. And modulus of the z will be root of 1 plus 1. That is my root 2. I can substitute both the values in the required expression of the log of z. You will get the expression this one. Fine. ज़्यादा से ज़्यादा इस पावर 2 को आप थोड़ा नीचे करके लिख सकते हो. ln of 2, इसमें से पाई एलसीएम ले लो आप, 8n plus 1 pi over 4 iota is the right answer of the problem. Look at the next one. Minus of 2. ये किस क्वाड्रेंट में लाई करता है? Lies in the second quadrant. You can see -2, 0. Fine. तो अगर सेकंड क्वाड्रेंट में लाई करता है, what is the angle? Tan inverse. I can write this number is plus iota into 0. Y is my 0. Fine. तो आंसर तो आया 0, लेकिन 0 तो फर्स्ट क्वाड्रेंट में है, -2 इज लाइक इन द सेकंड क्वाड्रेंट. तो इसका ऑपोजिट क्या है आपके पास? पाई. फाइन. So your tan inverse 0 by root is a pi. I can substitute ln of 2 plus iota 2n pi plus pi is the right answer of the problem. Okay, find all those complex values of the z which satisfy my given equations. So first of all 4 pi. अब आपको ये z निकालना ना, e raised to power z is equal to 4 iota. इसका क्या मतलब हुआ? Your target is to find the value of the log of 4 iota. तो फिर से वही करेंगे. इस 4 iota को देख लेते हैं कहाँ पे लाई करता है ये. x is 0, y is equal to 4. So this number lies in the first quadrant. अगर first quadrant में है, your target is to find the value of modulus of z and theta, principal argument. Fine. So can you find the principal argument? Find that is my tan inverse y 4, x is a 0. In the first quadrant, it is my pi by 2. I can substitute this number is my pi by 2. Can you find the modulus of z? So I can return this number is 0 plus 4 iota, that is 0 plus 4 square, 16 root, that is a 4. So that number will be my log of ln 4 plus iota 2n pi plus pi by 2 is the right answer. इस 4 को मैं क्या लिख सकता हूँ? ln of 2 square, then I can take in 2 is my outside, 2 ln 2 plus 4n plus 1 pi by 2 iota is the right answer. Okay, look at the next one. What is the meaning of that? I can write is a 1 over 2 log of minus 1. फाइन, यही होगा ना. लेकिन देखिए बच्चों, अगर तो ये रियल एनालिसिस होता, अगर यहाँ पे ये चीज होती 1 by x is equal to minus 1, then it has no solution. Why? Because in the real analysis log of minus 1 is undefined, but complex number में log negative defined है. Fine. So how you can write minus 1 plus iota 0. किस क्वाड्रेंट में लाई करता है ये? सेकेंड क्वाड्रेंट. Fine. Once we know it lies in the second quadrant, what is the value of the mod of z? Mod of z is my root of 1 plus 0, which is 1, and theta is my tan inverse y over x. In the second quadrant, 0 is not possible, so that's a pi. So therefore, what is the value of the log of minus 1? It is ln of modulus of the z plus iota 2n pi plus principal argument. Log 1 is 0. I can write as 2n plus 1 pi iota. Fine. And that number will be 1 over z. तो क्या आप z निकाल सकते हो? Z will be 1 over 2n plus 1 pi iota. Fine. अब iota हमें पता है डिनोमिनेटर में नहीं हो सकता कभी भी. Fine. So I can write is 1 over 2n plus 1 pi iota. I can multiply them. It's a iota square is my minus 1. 1 over iota को मैं ये लिख सकता हूँ ना, iota से multiply करा, that is the iota divided by iota square, which is my minus 1. So that is the right answer of the problem, where n has infinitely many values. Look at the third one, where it lies. You can see your target is to find z minus 1 is log of minus iota e cube. So firstly, you can see where it lies. Remember, e cube is a constant number. Fine. So I can write minus of iota e cube is, ऐसे ही तो होगा ना. So x is 0, y is my negative. So it lies in the third quadrant. Fine. और इस लाइन पे ये इस एक्सिस पे है ना, यहाँ पे एंगल कितना होता है आपके पास? minus pi by 2. Fine. So now तो यहां से आपका z कितना आ जाएगा? 1 प्लस log of. फाइन. तो आप z को कोई और नाम ले लेते हैं, z तो लिखा ही हुआ ना, w ले लेते हैं, माइनस आयोटा. फाइन. आपका टारगेट है log ऑफ w निकालना. तो क्या हो जाएगा? ln ऑफ w प्लस आयोटा टाइम्स 2n pi plus theta. So can you find the value of modulus of w? That's very simple. Real part is 0. Fine. Imaginary part is minus e raised to power 3. If you square, e raised to power 6, which is again e raised to power 3. Theta is my tan inverse y. Y is my minus e raised to power cube. X is my 0. So but we need us in the third quadrant. Answer is minus pi over 2. इस pi by 2 पॉजिटिव सेकंड क्वाड्रेंट में चला गया. तो आप यहाँ पे सब्स्टिट्यूशन कर दीजिए, तो आंसर कितना होगा? z is equal to 1 plus ln of e raised to power 3. So I can write as 3 ln of e plus iota 2n pi minus pi over 2. And again, what is the ln of e? Ln of e is my 1. So the answer is 3 plus iota 2n pi minus pi by 2. और 1 इसमें ऐड कर दो, 3 plus 1 is 4. So 4 plus iota 2n pi minus pi by 2 is the right answer of the problem. चलिए look at the last one. अब यहाँ पे आप देखिए फोर्थ ऑप्शन में डायरेक्टली आपको e की पावर z की फॉर्म में नहीं दे रखा आपको. फाइन. तो सबसे पहले हम फोर्थ पार्ट को थोड़ा सिंप्लीफाई कर लेते हैं. Clearly say this equation is my quadratic. Fine. So I can use the formula of roots finding, minus b square minus 4ac over 2a. minus b plus minus b square minus 4ac divided by 2, that is minus 1 plus minus root 3 iota divided by 2. फाइन, तो यहाँ पे दो केस बनेंगे. द फर्स्ट केस इज e रेस्ट टू पावर z इज minus 1 plus root 3 iota divided by 2. Second case is e raised to power z minus 1 minus root 3 iota divided by 2. फाइन, तो इस वाले केस से आपका टारगेट क्या है? योर टारगेट इज टू फाइंड द वैल्यू ऑफ द log ऑफ -1/2 plus √3 over 2 iota. Fine. And from this case, your target is to find the value of log of -1/2 minus √3/2 iota. फाइन. बस उसके बाद जिस तरह से फर्स्ट सेकंड थर्ड पार्ट करा आपने, ये किस क्वाड्रेंट में लाई करता है आपका? x is my negative, y is my positive. It lies in my second quadrant. Fine. Find the modulus of this number. Find and find the argument of this number. Similarly, ये आपका किस क्वाड्रेंट में लाई करता है? इट लाइज इन माई एक्स इज नेगेटिव, वाई इज नेगेटिव. थर्ड क्वाड्रेंट में लाई करता है. इसका मॉडुलस निकाल लीजिए, इसका आर्गुमेंट निकाल लीजिए, दोनों के आंसर अलग अलग निकालिए एंड देन यू विल गेट द वैल्यूज ऑफ द z is the required answer. So I think that you can do it by own. So I give you an exercise for you. The rest you can do it by own. Or second way is you can convert into the polar form. Fine. चॉइस आपकी, आप इसे पोलर फॉर्म में भी कन्वर्ट कर सकते हो r e रेस्ट पावर आयोटा थीटा के साथ. फाइन. और उसके बाद इसका लॉग ले लेना. इसका लॉग मैंने पहले बताया क्या होगा, लॉग ऑफ r प्लस आयोटा टाइम्स 2n पाई प्लस थीटा, जो भी आर्गुमेंट आएगा आपके पास. फाइन. और यहां से भी जो आर्गुमेंट आएगा, चॉइस आपकी है, यू विल गेट द आंसर्स. Now these questions are exercise for you. These 12 questions, find all those complex numbers of the logarithm functions and find the principal values of the logarithmic functions. इसको पहले आप z लेके which quadrant it lies, find the modulus value, argument, principal value बोला है आपको, n की वैल्यू 0 लेनी. Fine. You can solve it by own. Let me know if you have any doubt in this lecture. You can send me in the comment box. Fine. We will see the next lecture on the properties of the logarithmic function very soon. Till then, you can share this video, like and comment on this video. Best of luck, students. Happy learning.